Hello once again, welcome to our GEOCAMP series. In this discourse, I'll be talking about 4 different types of growth packages based on their mechanisms of formation. Now, a sediment or a stratigraphic unit is said to show growth if we have or see evidences of gradual or rapid changes in its thickness over a small area. The first mechanism or the first group of growth packages I'll show you are those impacted by prograding substrate or the underlying rock mass. The second groups are those which are actually influenced by synkinematic sedimentation. We have a third group of growth packages which are actually as a result of the original basin geometry, and then the last groups are those some that we find in compressional regimes where you have lots of thrust and asymmetrical anticlines and synclines. Now, this is a first example where you have where we have prograding substrate. Where we say prograding, where in this very context we're saying the substrate or the mobile rock mass underlying the main stratigraphic unit above is actually moving. In this case, let's say in one direction from the source, which probably is the hinterland, towards the basin on the right in this section. So what we see, or rather what we notice, is a thick and thin relationship between the overburden and the mobile substrate. So if you look at units 2 and 3, unit 2 is the mobile substrate. You notice that in areas where you have very thin mass of unit 2, that's a mobile substrate, you have a thick overburden, that's unit 3, and vice versa. So here what we see is that the growth or the wedging, sediment wedging of the overburden is being driven or is being impacted by the withdrawal or the movement in one direction of the underlying rock mass, in this case called the mobile substrate. So this is the second group of growth or second kind of growth, which is as a result of synkinematic sedimentation. Now, some authors will say it's syn sedimentary faulting or syn depositional kinematics. Is all the same thing. The most important thing is, supposing you have sediments moving, in this case, from the left to the right, that's from source on the left to the sink or the basinal area on the right. What we're saying is that the sedimentation or the deposition of this stratigraphic unit A happen at the same time as the occurrence of the normal faulting. So you have a thicker, so for each unit thickness of A that you see on the footwall as on your left, you're going to have a much thicker mass of that same stratigraphic unit on the right. So so this kind of growth is as a result of synkinematic sedimentation, also called syn sedimentary faulting or syn depositional kinematics. We have a third group of growth which is driven by the original geometry of the depositional of the basin itself. So in this very case, we're saying we have an originally, for example, saucer-shaped geometry like this. So sediments are going to fill in the basin, and then you're going to have a very thick unit of rock mass at the middle, and it's going to thin towards the sides, towards the sides of the basin. So such sections where you see very thick mass in the middle and then it thins away, or rather it shows or things in one direction, gives you a hint as to what the original geometry of the basin was. So in this very case, we're saying the basin was probably saucer shaped, and so we had sediments being dumped into a syncline or a depositional low, and you can also find this anyway in some situations on one flank of an anticline. So the last kind of growth packages I'll be showing are those driven by sediments, changes in thickness in areas where you have thrusting or asymmetric folds. So this is a typical, an example of a sketch that shows what that is about. So supposing we have on this to your left this thrust fault or reverse fault rather. So what we see is that if you look at the this stratigraphic units below, that's the dotted ones, you see it is quite thick at the middle and gets slightly thinner as you move away from the middle of this very section. Such kind of changes in thickness are being driven in this case by asymmetric folding or thrusting as shown. So that's all I got for now. Thank you very much. You can send me your feedback. Thank you to those who are already responding, sending emails and feedback. You can also chat us up on Facebook, send your feedbacks, and we like all the discussions going on there. And also, share your ideas even on YouTube. Until next time, thank you very much for listening.